Hello dear students. In this session we are going to solve a numerical on double integration method. A beam 4 meter long, simply supported at its ends, carries a point load W at its center. If the slope at the ends of the beam is not to exceed 1 degree, find the deflection at the center of the beam. So in this question, we are given with a beam of 4 meter long, simply supported at ends, carries a W load at center. It means that this type of simply supported beam where there is a load of W at the center, and it is given that the slope at the ends should not exceed 1 degree, right? So this slope at the ends, so this is the slope at the ends, so this is theta, right? This is theta at the ends, this is the slope, right? And the slope is maximum at the end, right? So theta is given that it should not exceed 1 degree, right? So it should be less than 1 degree. We have to find the deflection at the center of the beam, right? At center point, this point, what is the deflection? We have to find this deflection, right? At the center, right? This is the center point. So at center, we have to find the deflection. So we will use double integration method to solve this question. So let us solve this problem. A simply supported beam loaded with a point load at the center. This load is not given. This is given that this is a W load, right? It is unknown to us. And this is given that the maximum deflection, you know that for simply supported beam loaded with point load, or even in any case, the maximum slope is at the supports, right? And because it is at the center, so theta A will be equal to theta B if it is B, theta B. So theta A and theta B will be same in this case because it is uniform, right? And it is given that theta max should not exceed 1 degree. So this slope should be maximum 1 degree, right? Slope, or that is angle at the support, right? And it is also given that the length of the beam is 4 meter. We have to find out the maximum deflection, and the maximum deflection, you know, it is at the center. At the center the maximum deflection is there, right? And the formula is known to us that the maximum slope is given by, we already read in our theory lecture, that the maximum slope is given by WL square by 16 EI, and maximum deflection is at the center and given by WL cube by 48 EI. And we have to find out this maximum deflection. This is our question to find out the maximum deflection. So let us solve this question. Now theta A is given to us, means this quantity is given to us. So theta max is equal to WL square upon 16 EI. This thing is given to us, and this is given that it should not exceed 1 degree, more than 1 degree. So it is equal to 1 degree, and degree can be converted to radians because our questions are given in SI unit, because we have to solve in SI units. That's why 1 degree we have to convert into radians. So 1 degree will be equal to 1 multiplied by pi by 180 radians. This much radians, right? So we can get, now we have obtained this value WL square upon 16 EI. Now this is known to us that this much is equal to pi by 180 radians, right? Pi by 180 will be equal to 0.01745, or nearly equal to 5 radians. Now this is known to us, this quantity is known to us, right? And we have to find out this quantity, and this quantity is Y max. So Y max, which is at the center, that will be equal to WL cube by 48 EI, WL cube by 48 EI. This we have to find out. We can break it into two parts so that this quantity can be used here. So I can write it like this: 1 by 3 multiplied by WL square by 16 EI. This quantity 16 multiplied by 3 is 48. I have split it into two parts, 3 and 16. 48 can be split into two parts, and this L cube can also be split. Here we can write this is L, right? So this quantity is made separated so that this value can be used. Now Y max can be written as
one third of this quantity is 0.0175 multiplied by L. L is given to us, that is 4 meter, right? Or if you want to answer in millimeter, then it is 4000 millimeter. So 4000 millimeter. So this is one third of 0.0175 multiplied by 4000. This much millimeter. Answer will come in millimeter. So you can solve it using calculator and find out the value of Y max. What is the value of Y max? And it will come out to be 23.26 millimeter. When you solve it, you will get this answer, 23.26 millimeter. This is the answer of this question.